Happy Wednesday, my honors pre-calculus juniors. Today we're going to study the quotient rule. Remember yesterday you had a free, not a free, but you had a day to finish up your worksheet on the product rule. And remember you used that in a situation where you have two functions multiplied with each other. When you had plus, you got to take the derivative of the first one and the second one and just put a plus in there. If you had minus, you took the derivative of the first one and the second one and minused it. But for multiplication, you had to do that fancy schmancy rule, derivative of the first one, leave the second one alone, plus leave the first one alone and take the derivative of the second one. For division, it's also very similar. It's fancy schmancy, it's a little bit longer. You can't just take the derivative of the first one and the second one and divide them. That is not correct. You have to use something called the quotient rule. Okay? So here at the top, we have the quotient rule. You could box it or asterisk it so you could see the quotient rule. If you don't understand how it's read, I will explain it to you. D over dx, the derivative of a function divided by a function, is the derivative of the first one, leave the second one alone. Now we have a minus, and product rule is a plus. Leave the first one alone, and the second one you take a derivative of. What's new now is you divide by the second function squared. So the only real big difference between this one and product rule is that now there's a minus, and in the denominator, I put the second one squared. Okay? So almost the exact same formula, but slightly different. So here's an example of find the derivative of each expression. So here you see I have two functions divided by each other. What the non-smart calculus student would do is that he or she would take the derivative of the first one and then just divide the derivative of the second one. That is not correct. You have to use the quotient rule. Okay? Here is the correct way. I will take the derivative of the first one, so h prime x. And you may notice that the questions or the answers for these are very, very lengthy. It's okay. You could just leave it like that. Derivative of the first one, in this case it's 3x squared plus 10x. And I'll leave the second one, or the denominator, alone. Now it's a minus, not a plus. Leave the first one alone. And times the derivative of the second one, which is 2x. All over my denominator squared. That is the quotient rule. The math part of you probably wants to multiply this out, to distribute this, but for calculus, for quotient rule specifically, you're allowed to just leave it like that. Okay? So that is the derivative of h. Let's move on to the next one. Let me just move these over to the side. Another quotient rule problem, I have a function divided by a function. So y prime is the derivative of the first one, 2x. Leave the second one alone. Again, this is minus now. Leave the first one alone, and the derivative of the second one. Minus cosine x is the derivative of sine. All over my denominator squared. And maybe you don't know this, I think I've taught this to you before, but sine squared looks like that. Ugly, I know. And I know it's not very clean, but that's how you deal with the quotient rule problems. And the last one for quotient rule, I got a function divided by a function. But there's a catch here. When I take the derivative of the first one, do you see when I take the derivative of the first one, it's actually a product rule inside of a quotient rule? Okay? I know some of you are going to say, oh no, or good lord, but you can do this, okay? Derivative of the first one, okay? I'm taking the derivative of the first one, derivative here. I have to do product rule. 6x squared, leave the second one alone, cosine x, plus, remember this is product rule, leave the first one alone, and derivative of the second one, which is sine x. So within quotient rule, all I did was take the derivative of the first one. Then I leave the second one, or my denominator, alone. Okay? So this right here is the derivative of the first one, and this is the second one left alone. Minus, because this is quotient rule, I'll leave the first one alone, 2x to the third cosine x, times the derivative of the second one. And this is my second one, its derivative is 2x. All over the denominator squared. So if I'm going too fast, again, you could rewatch this on YouTube. All the videos will be posted up there. You could stop it and pause it, so you could write down the notes if you want to, but the only new wrinkle that I did now is when I took the derivative of the first one, when I took the derivative of this one, I had to use product rule. Then I left the second one alone. Minus, I left the first one alone. Derivative of the second one, denominator, all over my denominator square. And the last one we're going to do, again, is tangent and normal lines. I'm going to save doing normal lines for another time, so don't worry about normal lines. Only worry about tangent lines. Remember, every time they ask for the equation of a line, I'm going to start off with the point-slope formula. Okay, so that is y minus y1 equals m parentheses x minus x1. They gave us one of the pieces, x equals pi over 3. So I'll fill in pi over 3 there. To find y, all I have to do is plug in pi over 3 back into this function. Oops. All I gotta do is plug it back here. Okay. So I'll do a little side calculation. Sine of pi over 3 over 3 pi over 3 minus 5. Sine over pi over 3 you can do this in the calculator or in a calculator. Sine of pi over 3, 1, 2, 3, 1, 2, 3. You're going to get radical 3 over 2. Okay. So here at the top, I'll get radical 3 over 2. Over, this becomes just pi minus 5. Okay. And then I could move that down. Some of you may have forgotten your rules for fractions. This means the exact same thing as radical 3, 2 pi minus 10. So that is y. It's not pretty, but that's y. And then I have to find the slope. Okay. To find the slope, remember, means exact same as derivative. You'll notice in this particular problem, I have a function divided by function. So when I want the slope or derivative, I have to use quotient rule. Okay. So let's do a little side calculation. I'll just put it down here. I'll take the derivative of the first one, which is cosine. Oh no. Let me just move this real quick. Derivative of the first one, which is cosine x. Leave the second one alone. Yeah. Minus. Sorry, this is getting really messy. Let me just move this up for now. I'll bring it back. Minus. Leave the first one alone. Times the derivative of the second one, which is just 3. All over the second one, or denominator, squared. Now I'll plug in pi over 3. If I plug in pi over 3, cosine of pi over 3 is just half. Let me put it here. Half. Then pi over 3 here just becomes pi minus 5. This is getting out of control. Minus sine of pi over 3 we talked about was radical 3 over 2. And times 3, so that's going to be 9 over radical 2. On the bottom, if I put pi over 3 there, I'm going to have pi minus 5 squared. So this is really messy. This is the slope. Okay. And again, part of you will probably want to simplify this. It's okay. All you're going to do is take this and put it into... Gosh, why is this so bad now? All I'm going to do is plug it into m. Okay? So this is one really ugly answer, but that is the answer. That's the equation of the tangent line. If you don't get this, I understand. We'll do it in class tomorrow. I'll be back tomorrow, heaven forbid, or God willing. I'll be there tomorrow. Hopefully I'm safe. And for the rest of the class today, and also in class tomorrow, we'll catch up on product rule and quotient rule. Just as you do every day, as you've been recommending every day, your homework is to put online, reflect online about this particular topic. Tell me if you understand it, what you need help with, and that's pretty much it. So take care, and hopefully I'll see y'all tomorrow.